So in our last session we have seen how to use a sine wave in order to generate a musical note along with its envelope. In today's session what we are going to do is to study what is a musical scale, how to generate various notes, and how to generate a melody through a computer program, specifically using MATLAB. Alright, so let us start by answering the question as to what is a musical scale. Well, it's a set of notes with appropriate frequencies arranged in the ascending order of their frequencies. Now, what are the relations between the frequencies of various notes? That is the next question we ask. So it depends on what kind of scale you are using. There are two types. One is called as a natural scale, but in this ratio of frequencies of consecutive notes is not same. This we will discuss later. In today's session we are going to concentrate on a scale which is called as a equally tempered scale. In this, ratio of frequencies of consecutive notes is same and equals 2 raised to 1 by 12. Okay, so in order to see this more clearly, let us look at a few calculations for the tempered scale. So suppose your shadaj or sa has a frequency of 263.63 Hertz. This we have chosen. It could be some other frequency also, but this one corresponds to middle C on the piano, often labeled as C4 in the Western notation. Okay, so the next note, if you want to calculate, you multiply this reference frequency by 2 raised to 1 by 12, and what you get is a note called Komal Rishabh or C sharp. And if you want to find the next note, that is Shuddha Rishabh, then you multiply the reference frequency by 2 raised to 2 by 12. So notice this is Shuddha Rishabh, this is Komal Rishabh, and if you take the ratio of these two, you get 2 raised to 1 by 12. And in fact, as you go on generating various notes, the ratio of the consecutive notes frequencies is always 2 raised to 1 by 12. So as I said, this one is called as a Shuddha Rishabh or D in Western notation. In general, a note frequency is obtained by f into 2 raised to n by 12, where n varies from 0 to 11, where f is the reference frequency, which in this case is 263.63. We'll see why this number is changing from 0 to 11 as we look at the next table. By the way, note that after n equal to 11, when n is 12, this is 2 raised to 12 by 12, so that is 2 into f itself. That is the next frequency, and this is where the next octave starts. Okay, so to take a look at all the frequencies, let us take a look at this table which shows all the notes in one octave. So here I have shown the number n, which is useful for calculating the frequencies. So it's starts from 0, goes up to 11 and goes up to 12, but when n is equal to 12, that is the start of the new octave. Alright, so what are the notes? This is Shadaj, this is Komal Rishabh, this is Shuddha Rishabh, this is Komal Gandhar, this is Shuddha Gandhar, Shuddha Madhyam, Tivra Madhyam, Pancham, Komal Daivat, Shuddha Daivat, Komal Nishad, Shuddha Nishad, and then the upper Shadaj, that is the Tar Saptak Shadaj. The corresponding Western notations are C, C sharp, D, etc. You can read through. And in this case, we have assumed that this frequency corresponds to 261.63. But for generating appropriate notes, it is not necessary that you must have this frequency. This is one of the possible frequencies which corresponds to C4 on the piano, the middle C, but it could be some other frequency as well. Alright, so as we have already said, frequency can be calculated for any note as 261.63 multiplied by 2 raised to n by 12. So you pick n from here and multiply it by the reference frequency and you get this frequency. That is how all these frequencies are calculated. And you can see that this base frequency, after one octave, it reaches exactly double frequency. This is 2 times this particular frequency. So this tells us that in one octave of the musical scale we got exactly 12 notes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the next octave starts where the frequency is exactly 2 times this. Now when music is generated, when melodies are created, more than one octave is often used, and we are going to concentrate on 3 octaves, although more also could be used, but we are going to concentrate on 3 octaves where most of the melodies can be created. So this we call as the lowest octave or the lower octave, and we use a suffix m to show that this is the mandra saptak. So in English you can call it as lower saptak, middle saptak and upper saptak. In Indian convention, the lowest saptak is called as mandra saptak, then madhya saptak and tar saptak. Actually I have written tivra saptak, but it is really called tar saptak. Okay. Now in order to distinguish the various octaves, I have given a suffix here. So this is shadaj from mandra saptak, this komal rishabh from mandra saptak. Everywhere I have used m. Where I have not used any suffix, it means it's a middle octave, and where I have used T, it means tar saptak. Okay. Now the starting frequency for the mandra saptak is 130.815, and double that is the frequency for the madhya saptak, and double this is the frequency for the tar saptak. So if you consider this as our reference frequency, the madhya saptak shadaj is 2 times and the tar saptak shadaj is 4 times this frequency. Note this. Okay. Now what are melodies? So these are appropriate sequence of notes with each note having appropriate duration. Now what do we mean by appropriate sequence? So appropriate sequence of notes is that sequence which will make melody sound sweet, sound good, which of course means that there are no set rules for this, although there are certainly certain rules in music which are often followed. However, this is more of a subjective thing, and the process is the creative process. So appropriate sequence is not a mathematical certainty. It depends on how the music director is creating his sequence. And appropriate durations. If the note durations are appropriate, then it will make the melody sound rhythmic. Here there is a little more structure, and certain rules must be followed in order to make the melody rhythmic. Now note that although in an octave there are 12 notes, most of the melodies are such that they use much less than 12. Typical numbers are, you might use only 5 notes, or you might use 6 or 7. Of course you could use notes in all the 3 octaves, but the number of notes in each octave are limited to 5, 6 or 7. Since a melody consists of many notes, it is useful to define a function which can be used repeatedly to generate these notes. So let us see what this function is. The one function that we have written, its name is note G1, and tone is the output parameter which returns the note, and S, N and D are the input parameters. So let us discuss these parameters first in order to get the understanding of the working of the function. Then we'll look at the code proper. So as I said, tone is the output, this returns the note. S, N and D are the input parameters. So let us now take a look at each of the parameters. So S denotes saptak. So S equal to 1 means mandra saptak. So if I want to generate a note in the mandra saptak, when I call this function, I must pass 1 in the first as the first parameter. S equal to 2 means madhya saptak, and S equal to 3 means tar saptak. Then small n means the note number. We have already seen that different notes have different numbers, and you have to pass on the appropriate number. For example, if n equal to 0, then 2 raised to 0 by 12 is 1, so you will get the shadaj itself. N equal to 1 will give you komal rishabh and so on. and d is the duration of the note in seconds. Now the base frequency f has to be defined in the function. Note that this is the frequency of Shadaj in the Mandra Saptak. The way the function is written, our reference frequency corresponds to Shadaj in the Mandra Saptak. Once you know f, then if you know the correct value of this capital N, you can find out the note frequency. Now this variable n, it depends on what? It depends on the saptak that you are using, S, and the note number. So if S is equal to 1, that is Mandra Saptak, then n is 2 raised to n by 12. Small n corresponds to the note number. And if S is equal to 2, we have seen it is double the frequency of the Mandra Saptak. So this has to be multiplied by 2. And if S is equal to 3, the Tar Saptak number, remember, is 4 times that in the Mandra Saptak. So I have to multiply this by 4. Once n is obtained by using the values of S and n which are passed by the calling function, calling program, then n is obtained. Now what you do, define t vector using d. D is the duration of the note, so you generate a t vector using that. We in earlier sessions we have seen how to generate this t vector. Then using f1 and t, generate note and then return. So this explains the various variables that are used in this note function. So tone is the output, S and D are the input. So this is the actual program, and it's easy to understand now. So function tone is equal to note G1 S and D. This is the definition of the function. If S is equal to 1, n is 2 raised to n by 12. Else if S is equal to 2, you multiply this by 2. Else you multiply this by 4. So this will give you Mandra Saptak, Madhya Saptak n, Mandra Saptak here, Madhya Saptak here, and Tar Saptak here. Then define the reference frequency, which in this case we have defined as 130.815, because this corresponds to the middle C on the piano in the Madhya Saptak. This is exactly half of that, because the reference frequency is in the Mandra Saptak. Then you generate f1 because n is already generated, so multiply the reference frequency by n. Then generate the t vector as we have seen before, generate the envelope, generate the sign note, generate the tone, and then return. So this function can be repeatedly used in order to generate various notes, and then you can put those notes in certain sequences in order to generate the melody. But let us say something more about this reference duration, D. So just as you need a reference frequency to generate various notes, you need a reference duration, and D is our reference duration. So in Indian notation, this is called as 1 matra. So D equal to 0.4 in our program means 1 matra is of 0.4 second duration. You can have notes of 1 matra or half matra, that will be only of 0.2 second, double matra 0.8 seconds, by passing appropriate value to this variable D to the function. In Western terms, if you want to understand this, then one way of doing it is to consider this D equal to 0.4 as the duration of a quarter note. Then 0.8 second will correspond to half note, etc. So this is the significance of this reference duration D. Alright. So we are now ready to create our melody. So this is as usual, clear console, clear variables, define D equal to 0.4, this is the reference duration. Now I generate ST2. Now I have used this particular symbol. S means I want to generate Shadaj. ST means I want to generate Tar Saptak Shadaj. And 2 means I want to generate Shadaj of 2 times the reference duration. 2 matras. That is what I want to generate. So since this is Tar Saptak, my S parameter is 3. Since it is Shadaj, my N parameter is 0. And since it is 2 matra, the third parameter is 2 times D, because D is the reference matra, reference duration corresponding to 1 matra. Similarly, I generate S2, that is note G1. 2 means Madhya Saptak, 0 means Shadaj, and 2 means I want double duration. Then I generate Shuddha Rishabh, so in Madhya Saptak. So Madhya Saptak, Shuddha Rishabh I am generating. 2 corresponds to small n equal to 2. If you refer to the table, you will understand that this corresponds to the Shuddha Rishabh. And finally, I want just one matra for this Shuddha Rishabh. So I generate all these notes ST2, S2, R, G, P, D, and then I put them in sequence. So X1 is ST2 followed by D, P, G, R, S2. Then I generate, so this is simply a sequence of notes which are in the ascending order of frequency. This is in the descending order of frequency. And then I generate X2, which is in the ascending order of frequency. Then I generate my final melody, which is a concatenation of all these. So I put X1, which means this entire sequence come here. Then I put X2, which means that this entire sequence comes here. Then again I repeat this X1 and repeat X2. So if you calculate the number of matras in this 2, 3, 4, 5, 6, 7, 8. 8 matras in each of these sequences. So you'll get 32 notes in this sequence. Then you send it to the sound card and store it in the file, which I'll now play. So let's see how it sounds. Alright, so in this session we have seen what is a musical scale, what is a tempered scale, how to generate various notes through the program, and how to create a melody. And that's all in this particular session.